In this section, we'll take a look at the cases where we do not know the standard deviation for the whole population. So just like in the last chapter, these were the cases where you had to use the t-distribution. So we'll be using, instead of a t-interval, we'll be using a t-test. As before, we still need our sample size to be over 30 if we don't have a normal distribution. But this time we won't know sigma, so we'll be using the t-test. In the flowchart, we'll pretty much be doing the same directions as we did in the last section, just when we get to the bottom we'll choose T instead of Z. The calculator screen looks just a little bit different. You'll go Stat Test, it'll be the second choice, T-Test. You'll still have the mu0 for the claim. The X bar's in there, but notice the order of the mean and the standard deviation have flipped from the last section. X bar's first, and then the S, which is the standard deviation for the sample. And then N, and then the alternative hypothesis. Very similar screen will come up, find the p-value, compare it to the significance level. And we're still coming back to these same 5 steps. Make sure that you're walking through and giving me all of that information. So let's run through some examples. Nutritionist claims that the mean daily consumption of fiber for a specific age group of males is less than 20 grams per day. So that's the claim, less than 20. Study done, 457 males, mean intake of 19.1, standard deviation of 9.1. So notice here that that standard deviation is in the same sentence talking about the sample of 457 males. This is not a population standard deviation, it is a sample standard deviation. That means since we don't have a population standard deviation anywhere in this problem, we're going to have to do a t-test. We do have 457 in our sample, so that's way over 30, so we're fine there. So we've got an N of 457, an X bar of 19.1, and an S of 9.1. So we'll have to do a t-test because we only have S. So first we need to set up our hypotheses. The claim is that the mean is less than 20, so mu less than 20 in the alternative. That makes the null mu equal to 20. We're going to do a t-test in this case. So we go into stat tests, pick number 2. We do have the mean and the standard deviation, so we want the stats setting, not data. And then we'll put in the claim of 20, X bar, S, N. We have a less than in our alternative, so we'll choose that and then calculate. And that'll bring up your screen with your p-value. 3 significant digits, 0.0175. Our significance level in this problem is 0.05. We're definitely smaller than that, so that's small enough to reject. We're rejecting the null. That means we're going to support the alternative, which was the claim, so that's the one we want to talk about. We don't have the word fail in here, so we do have sufficient evidence. So there's sufficient evidence to conclude that the mean daily consumption for all 20 to 39-year-old males is less than 20 grams. In this example, the average household expenditure in 97 for energy was $13.38. An economist wants to know if it has changed since then. So that's the claim, is that it's changed. Random sample of 35, that's over 30, so we're safe. That sample had a mean and a standard deviation that are given. So the standard deviation only goes with the sample. 0.05 level of significance. So we've got an N, an X bar, and an S. Our claim is that it has changed, which means that it is not equal to 1338 anymore. So that's our alternative, mu not equal to 1338. It doesn't say whether he thinks it's increased or decreased, just says changed. So that's what we do. And then that makes the null equal to 1338. We only have S, so it's a t-test. Stat tests, put the information in, and then it's going to bring up a p-value of 0.126. So that's 12.6%. Our significance level was 0.05. That's definitely more than 0.05. So that is not small enough to reject. We fail to reject the null. That means we fail to support the alternative. The word fails in there, so there's not sufficient evidence to conclude that the mean expenditure for all households has changed. In this example, a fishing line company produces a 10-pound test line. We've got a sample of 12 randomly selected spools. We've got a mean and a standard deviation. So we pull all of that information out of the problem, and we're supposed to test that the line is not up to the specifications. Well, we've actually got a problem here because we're not told that there's a normal distribution, and the sample is only 12, so we're not over 30. This is not going to work with the methods that we have in this class, so you're going to need to consult a statistician or say that the sample size isn't large enough to assume normality. The cases where you're dealing with an actual list of data often end up being t-tests, so let's go ahead and do a couple examples of those here. So we have a nursing student. She believes that the males on her floor have a mean blood pressure less than 130. So she samples 19 patients, and there's the list of all of their blood pressures. Now, there's only 19, but we are told that it's normally distributed. We are not given a population standard deviation. You could have a data case that then said, assume the population standard deviation is whatever, and then it would be a z-test, and the z-test also has a data option. But this one does not give us a population standard deviation, so this one will end up being a t-test. So we'll have to go to Stat Edit. You've done this before. Put the data in under L1, and then when you go to your t-test, you'll need to change the stats option over to data. First though, let's go ahead and set up our claim. So our hypothesis would be that mu is less than 130 for the males on her floor. That makes the null equal to 130. So we go into stat tests, we change it over to data, we put in that the claim is 130, tell it which list you put your information under. Leave the frequency alone, put in the less than for the alternative, and then calculate. You'll end up with a p-value of 0.0879. Our significance level is 0.05, so our 0.0879 is larger than that. That is not small enough to reject, so we'll fail to reject the null, which means we fail to support the alternative, which means we do not have sufficient evidence to support that claim that the blood pressure for all of the male patients on her floor is lower. So here's another one for you to try. Bats emit high-frequency sounds. Researchers want to test the claim that the range of bats for these sounds is more than 35 centimeters. So they do a sample of 11 bats. We're going to assume the population is normal so that 11 is okay. So go ahead and run through the 5 steps, pause it, and then I will let you know what the answer is. So the claim was that the range for all bats is more than 35, so mu greater than 35 for the alternative. That makes the null mu equal to 35. This is a t-test because we have no population standard deviation given. So, and it'll be a data, so stat edit, put the information under L1, and then go to stat tests, make sure it's set on data, and then put everything in, calculate p-value 0.0171. We've got a significance level of 0.05, so we're smaller than that. We're small enough to reject the null and support the alternative, so we do have sufficient evidence to support the claim that the mean range of all bats, not just these 11, but of all bats, is more than 35 centimeters.